Okay, in this video we're having a look at the square root function, which is linked to 4c. Okay, so square root function is root x. Okay, remembering that? Okay, so we know that there is a link between x squared and the square root of x. Okay, so it makes sense then that there would be a link between their graphs. Okay, so here we've got y equals x squared. What happens is if we rotate that around 90 degrees, we actually get our two parts of our square root function. Okay, so this one is the one that we really care about, which is y equals the square root of x. The bottom half is y equals negative square root of x. Okay, and we talk about that a little bit later on, just being a reflection of this. So what we're really talking about is this red part here. Okay, if we put those together, okay, they're actually x equals y squared. Well, this one is y equals x squared. Okay, this full one here is actually x equals y squared. Okay, so we're just looking at this part of the graph. Okay, so this half, okay, is that quadratic, half of this quadratic sort of shape, or this parabolic shape. Okay, so remember that square root of x is the same as x to the power half. We need to remember that. That's going to be really important. Okay, now as in our hyperbolas and our truncus, we can put it in our interesting point form. Okay, so we can say that we've got y equals a outside of the square root of x take h plus k, or that y equals a outside of x take h to the half plus k. I prefer this one, okay, purely because every single function that we have seen can be put in this form. Previously, okay, we had it as whole numbers, where we had it squared, cubes, that sort of thing. Now we're talking about where we've had it to the power of -1, to the power of -2, now we're saying to the power of a half. And all these things still work. Everything we've spoken about for hyperbolas and truncuses still work. Okay, so what's the interesting point? Okay, well, when we had this as squared, okay, that was our turning point form, and it was actually our turning point here. Okay, so for this one, it's not really a turning point because we're only talking about the top part, but it would equate to this point, which is really the end point. Okay, so it's the end point. So that means that our end point is at the point HK. Remember, we're switching our sign. Okay, if this was -3, that becomes +3. K stays the same. Okay, and once again, A is that dilation factor. That's the thing that, remember, stretches or compresses. Okay, and depending on what's happening. So, we've got a little bit more that we'll look at. Okay, so what happens when that A is negative? Okay, so when that A is negative, we get that other half of that graph that we had. Okay, so this is our reflection. Formally, though, it's known as a reflection of the x-axis. It's reflected down. So it was up here. Okay, it was up there. Now it's being reflected down. Okay, how about the negatives inside our inside our square root sign? Okay, this is a reflection of the y-axis. Now you may be thinking, well, hang on, I can't take the square root of a negative number. But remember here, okay, these values of x along here were negative. We're now multiplying them by a negative, which makes them positive. So these ones exist. These ones over here, though, that were positive, okay, have now been times by a negative, and we can't take the square root of a negative. So that's why we're never going to see a value over here. And that's really why for our normal graph, this one up here, it's only these positive values, because we can't take the square root of a negative. So we can't have any sort of a function over here. Okay, so we've got a couple of examples to have a look at now. Okay, I've actually had to graph these. So we've got graph y equals 2 outside of the square root of x plus 3. Okay, so first of all, we need some axes here. Okay, and we need to think about what's happening here. So we've got that 2 is a dilation factor. That's fine, we can worry about that later on. Okay, and then we've got this x plus 3. So it's been translated, so that's horizontally, because it's inside our brackets, left and right. Because it's +3, okay, remember, we change the sign. So that endpoint now, instead of being here at 0, it becomes -3. Or the way to think about, okay, is when it's +3, it's being moved to the left. So it's going to come over here, okay, and it's going to be at -3. Okay, we know our endpoint's there. Now, how do we take care of this 2? Well, all we've got to do is show some other point. Okay, the easiest point to show is our y-intercept, because we know it's not being reflected, so it's going to go up like that. So we need to show this y-intercept. So remember, we let x equal 0, so you say y equals 2 times square root of 0 plus 3, which is just simply 2 root 3. Okay, remember root 3 is about, if you're trying to get some sort of scale or context, root 3 is like 1.86. Okay, so we're double that. We're around about, what, 3.7 or so. So we're up here somewhere. Okay, so we're coming through. Oops, I've gone far too steep there. Okay, we're coming through something like that, and that is 2 root 3. Remember, don't change that to a decimal. Okay, you don't need to. Okay, leave it in the exact form. That's how you should have it. Okay, so that's what this one would look like. This one here, a little bit different. Okay, so we've got y equals the square root of x take 3, take 2. So that take 2 is outside our square root sign. Okay, so we need to be, actually, sorry, that's not what I want to do. Sorry, I want it to be 3 take x. Okay, to show you something here. Okay, this is a really common way that you could see a question where they're trying to screw you a little bit. Okay, we need to rewrite this because you can see in all our forms, okay, we always have x first. Okay, so we need to think then that we've got y equals the square root of negative x plus 3. Okay, take 2. Okay, now, you could be thinking that this is similar to this one here. Okay, I'm plus 3, so I'm going to move it to the left. It's going to be over there. That's true, except we've got a negative here. Okay, if we have a look back, where have I got it? No, I don't have it. We need to talk about it. Okay, so what we need to do here, right, is we need to take out the negative as a common factor. So this will actually become the square root of negative x take 3. Take 2. Now you might think that seems like a really trivial step, but look at this. It's changed the sign now on our 3. So this is now negative 3. Okay, and we have to do that, otherwise we're going to get our translation wrong. So when we graph this now, right, we know now that our interesting point, that endpoint, has been moved across to the right by 3 and down by 2. So if this is 3, this is 2. And my endpoint is down here. Sorry, negative 2. My endpoint is down here now. Okay, and we're going to come up like this. Okay, now we can see there that we're not going to have a y-intercept, okay, but we should be getting this x-intercept, which is when y equals 0. So we say 0 equals square root of negative x plus 3, take 2. Now add my 2 on. 2 equals the square root of negative x plus 3. Okay, I'm going to square that now and get 4 equals negative x plus 3. Okay, now I need to take away my 3 here. No, I've mucked something up there. I've absolutely mucked something up. What have I mucked up? Because I am... Oh, I know what I've mucked up. Sorry, we need to go back a step. Mucked up my graph here. Because we're saying now, I forgot something really important. We forgot about this negative here. Okay, we've got this case here. It's actually been reflected. Okay, so it's been reflected and now it goes like this. I shouldn't have rubbed out that red, that was fine. Now I'm drawing this deceptive. Okay, I probably should go back to what I had here. Sorry guys. If we go back here and we say that we've got our 0 equals our square root of 3 take x, take 2, add our 2, 3 take x. Okay, square 4 equals the square root of 3 take, just 3 take x now. Okay, take away our 3, 1 equals negative x, so x equals negative 1. So we know our x-intercept, okay, is here at negative 1. Okay, so what's happening is it's going like this through. Okay, my scale just didn't do that graph a lot of justice. Okay, so we're going to be looking something like that. So we've got this endpoint here, which is at 3, negative 2, okay, and we're coming through here, okay, at negative 1 is what we've found from there. Okay, so what do we need to really remember about these? Okay, remember about these endpoints, okay, and where it's going to put, but this is a really key worked example. Sorry, I made that mistake in there. In that, going from here to there and then there to there is critical for the success of these questions. We have to remember to take out that negative as a common factor so that we end up moving the right way. Okay, so look, hopefully that will help you out a fair bit with 4C. We do it again, we do square root functions next year again as well. Okay, so it's nice, it's something that we'll see more than once.